Alright, so this is our next question from Cat 24, the second slot. I'm not yet sure whether this was the exact question asked, but that's okay. I mean, when the response sheet is out, I'll cross check every question and I'm going to solve each and every question for you guys. So let's look at this question and attempt it for time being. Okay, so this year kind of marks the return of remainders. So I've seen a remainder question in every slot of Cat. So very surprising, and yes, many questions were very easy. Okay, so probably in the exam setting they would have targeted or they would have kept these questions as sitters probably. So just pause the video and give this one a try, and then you can resume the video for the solution, guys. Okay, so the first or the conventional way of solving the question is we basically find a power of 3 which gives the remainder 1 or minus 1 with any multiple of 11. I'll again repeat. We want a power of 3 which gives the remainder 1 or minus 1 with any multiple of 11. So let's try. 3 on dividing by 11 will give you a remainder 3 only. 3 square is basically 9. On dividing with 11 gives the remainder of 9 or minus 2. Nope. What about 3 cube? 3 cube divided by 11, the remainder is 5. Again, not happening. 3 raised to 4 is 81. On dividing with 11, the remainder is 4. Again, not happening. 3 raised to 5 is 243. On dividing with 11, the remainder is 1. Yes, this is exactly what we need to answer the question here. 3 raised to 5 on dividing with 11 gives you remainder 1. Right? So what we will do next is we will split the number 333 into 3 raised to 330 into 3 raised to 3. And now our job is almost done because 330 is a multiple of 5. We can further break this 330 as 5 into 66. So the first part becomes 3 raised to 5 into 66, which is further going down to become 3 raised to 5 the whole raised to 66. And 3 cube is nothing but 27 as it is. Now, as you've seen previously, 3 raised to 5 is nothing but 243. So 243 raised to 66 into 27. We want the remainder of this entire thing with 11. So we know that 3 raised to 5 or 243 on dividing with 11 gives the remainder 1. So the first part becomes 1 raised to 66 into 27 divided by 11. 11 2s are 22. The remainder is 5. 1 power 66 is 1 only. 1 into 5, the final remainder will be 5. Okay, so pretty straightforward approach. It's not too difficult. If you have been solving questions of remainders, you would have already come across this particular approach, and you may already seen what to do in this particular case. But now I'll tell you a quick shortcut to solve this particular question. So we can solve this question very quickly using the Euler's theorem or the Euler's quotient. The divisor here is 11, right? We first find out the Euler's number of 11. If you want to understand more about this Euler's number or the Euler's quotient, you can check out the course link in the description. I've explained the Euler's quotient and other shortcuts of remainders theorem in my course. So find out the Euler's number for 11 first, and that is basically 10. Okay, so all multiples of 10 in this power will give you remainder 1 when divided by 11. So technically, the nearest multiple of 10 before 333 is basically 330. So 3 raised to 330 on dividing by 11 will give you a remainder 1 only. Right? So you don't even need to look any further. You directly change your question to 3 raised to 3 divided by 11, because before that up to 3 raised to 330 the remainder was 1 only. The extra powers of 3 are 3 cube. So now the question simply becomes the remainder of 27 with 11, and the remainder we need is 5. That's the answer to our question, and that's how we can solve it much quickly, rather mentally, without even lifting up the pen. If we know the Euler's quotient or the Euler's theorem, the answer will be remainder of 3 raised to 333 divided by 11 will be 5.